Welcome. Now we will discuss the magnification of lenses. So we know that the size of the images are increasing or decreasing. To know whether the size of the image is increased or decreased in case of lenses, we use magnification. So let's derive the formula for the magnification. So let us take a convex lens. Here I am using convex lens to derive that magnification formula. P, that optical center, and focal points of two surfaces, and here I kept a object in front of a concave lens and a light ray passing from the top tip of the object parallel to the principal axis. After incidenting, it passes from the focal point, and one more light ray incidenting at optical center. Without deviation, it passes forward. So here the two light rays intersecting, refracted light rays intersecting, there the image is formed. So let us say the object is O dash and the image is I dash. From this figure we can find two similar triangles. First one is O dash P, and the second one is I dash P. So these two are similar triangle O dash P and triangle I dash P are similar. Okay, then from the similar triangles we can write I dash by O dash and IP by OP. So then what is I dash? I dash is the height of the image. So the image height denoted with HI, and O dash is the height of the object HO. Then IP, what is IP? Here this is the distance of the image. Generally the distance of images denoted with V. Then OP, this is the distance of the object. So distance of the object is denoted with U, and this is said to be the formula for the magnification. So the magnification is HI by HO or V by U. So here we need to apply sign convention parameters. So here HI below the principal axis negative. The heights which are taken below the principal axis are negative, above the principal axis are positive. So the magnification M equal to minus HI by, and the height of the object above the principal axis, that is positive, and next V, the distance of image. We are measuring in the direction of incident light ray, so the distance of image is positive, and next U, the distance of the object. We are measuring opposite to incident light ray, so this value taken as negative. Minus get cancelled, so the magnification is HI by HO V by U. This is the formula for the magnification in case of lenses. So here if the magnification value M equal to 1, then it means whenever the object placed on C, the image also formed on the C. So then the distance of the image and distance of the object both similar. We already discussed in the ray diagrams. And the size of the object when we keep on the C, center of curvature, the image also falls on the C, and the same height equal to that object. This is about the magnification of lenses. Thank you.